So our next topic is about seismic waves. That is about earthquake waves. So now let us see how earthquake takes place and what are seismic waves. Actually, if you take our earth structure, earth structure is majorly consists of three parts. One is crust, another one is mantle, then third one is core, and the depth of the crust is approximately about 100 kilometers, and in the case of mantle it is about up to 3000 kilometers, and depth of the core is ranges up to 3000 to 6700 kilometers. So if any fault is there in any one of the part, because of the fault, there is fault and dislocation. Dislocations will take place. These dislocations move different layers and it leads to transmission of energy as waves, in the form of waves, and these waves are said to be seismic waves. Seismic waves. One can classify seismic waves as follows. So seismic waves are earthquake waves. Also these are all comes under the category of mechanical waves. So mechanical wave means it is a kind of sound wave. So its range is frequency range is less than 100 hertz. Seismic waves frequency range is 1100 hertz, less than 1100 hertz. So one can classify seismic waves. There are various causes of seismic waves. It may be caused by the impact of any asteroids, and of course because of earthquakes and huge explosions. So all these things generate these seismic waves or mechanical waves, or it transmits energy across Earth's rock in the form of waves, and based on the directions of energy transmission as well as wave propagation direction, and that is material movement direction, these waves are further classified as like this. There is majorly it is classified as body waves, and surface waves. Body waves and surface waves. Body waves are further classified into two types. One is P wave and S wave. Yeah, surface waves are classified into two. One is Rayleigh waves, and another one is love waves. Here, these P waves or primary waves are also said to be longitudinal waves. Are also said to be longitudinal waves or compressional waves. Compressional waves. Here, these S waves are also said to be transverse waves or shear waves. So, alternatively called as transverse or shear waves. And in this case, Rayleigh waves can be further classified into two types. One is, of course, longitudinal and second one is transverse. And love waves are of only one type, longitudinal. So it is all based on the material propagation direction, movement of material, and energy transmission direction. These waves are classified in many aspects. So in general, one can say body waves and surface waves are there. Body waves moves across the Earth's internal body, whereas surface waves moves on surface only. And in general, body waves moves faster than surface waves. Body waves moves faster than surface waves. Now let us see these waves one by one. First, let us start with the surface waves. Surface waves, that is Rayleigh waves. Rayleigh waves, as I already told you, in this case, matter, that is mass, moves up and down. Mass moves up and down. Moves in the up and down direction. So I just roughly draw the diagram of Rayleigh wave propagation and energy transmission. The direction of energy transmission is in this direction. This spot segment is undisturbed. Undisturbed ground. and this is disturbed ground. So energy transmission takes place in this direction, whereas movement of mass takes place like this. That is up and down motion. So up motion as well as down motion. So matter moves upwards as well as downwards. So what is the speed of the Rayleigh waves? Rayleigh waves moves, its speed is 10 times greater than the speed of sound waves in atmospheric air. So it's about 340 340 meter per second into 10 times. So it is about 3400 meter per second. Its speed is about 3400 meters per second. Of course, since it is a transverse wave, its speed must be relatively smaller than any other wave which moves longitudinally. So, however, its speed of these Rayleigh waves are faster than normal sound waves. So, the next one is love waves. So love waves are another kind of surface waves. And it moves longitudinally. That is, matter moves, the direction of mass movement is along the direction of energy transmission. Okay, so in this case, mass moves left and right. So left and right motion. I just roughly draw its propagation. So this is undisturbed ground. Undisturbed ground. Here, the wave propagation or energy transmission direction is this direction. Direction of energy transmission is along x-axis, means, or that is wave propagation direction is in this way, means left to right. So matter moves this way and this way, left to right. So mouse moves left to right and it's perpendicular to it. Energy transmission or propagation wave propagation occurs. So it is a kind of longitudinal waves. And of course, since it is a longitudinal waves, its speed of these love waves are greater than Rayleigh waves, which are one type of surface waves. So its speed is from roughly from 2000 to maximum 6000 meters per second. Its speed is 2000 to 6000 meters per second. Since it is a longitudinal wave, its speed is greater than that of the Rayleigh waves, which moves comparatively slower than longitudinal waves. So first, these waves are usually among surface waves. There is love waves and Rayleigh waves. Love waves are felt first. Okay, so love waves are felt first, or love waves are realized first. Okay, so the next name, body waves. Again, body waves are classified, as I already told you, as P wave and secondly S wave. So P wave means it is a primary wave. You can call it in many ways as primary waves, compressional waves, and longitudinal waves like that. So in this case, suppose so as you know, body waves moves inside within the Earth system, unlike surface waves which moves on the surface of the Earth, whereas body waves moves through the rocks and other materials of the Earth. Suppose if any huge force is applied to any part of the Earth, the origin of the force may be any asteroid impact, or one example is asteroid impact. If any asteroid impacts the Earth externally, so when it collides with the Earth, matter in the Earth are getting compressed. So regions of compression will be generated. Compression zones will be generated. Regions of compressional zones will be generated, and also dilated regions in between compression, dilated zones will be developed. That is, matter moves, matter and energy released by the impact of the asteroid altogether moves in this longitudinal direction. So longitudinal direction. So some regions are compressed and some alternative regions are dilated. So in this way, matter moves and energy transmission or else wave propagation occurs in the same directions. So these waves, that is, it takes place throughout the body of the Earth, that is within the Earth system. Okay, and these type of waves, that is P waves, are able to pass through solids, solid part of Earth and fluid part of Earth. So this compression and dilation is possible in these two cases, that is solids and fluids. So fluids means, maybe here in this case it is liquid or sea water. So compression and regions of compression and dilation is possible for liquid and solid. So P waves can able to pass through solids as well as fluid part of Earth. So if you look at S wave, as I already told you, S waves are said to be shear waves. Shear waves. So shear stress is possible only for solids. So shear strain means some few layers of any solid material will be dislocated or displaced. Okay, and so this is not possible. This type of strain is not possible for fluids, that is liquids and gases. So shear waves or S waves are able to pass only through solid part of Earth. Okay. So of course, and among these P and S waves, P waves moves faster because it is longitudinal waves, whereas S waves moves slower. In the case of highly dense medium, highly dense rocks and strengthened material, stronger rocks, the velocity will be usually greater than the lighter medium, that is poor dense materials and the layers of the Earth, the velocity would be smaller. Okay. However, P waves velocity is, in general, its velocity is greater than the velocity of or speed of S waves. So the next one is if you draw roughly and this position for a roughly this part is said to be focus or hypocenter. Focus or hypocenter, and this point is said to be epicenter. So focus or hypocenter means from where P wave and S wave, this focus or hypocenter is caused by the fault. Any fault or some dislocations, because of that focus or hypocenter is formed, and from where earthquake takes place. Okay, so P and S waves emanate from the focus and hypocenter, and since P waves moves faster than S wave, it reaches first. It reaches first. Okay, whereas S waves takes longer time, like this. Okay. Also they move slowly, like this. And when they reach the surface, P and S waves reach the surface, from where it starts to emanate as surface waves. Okay, surface waves. And these surface waves, from the point on the surface of Earth, surface waves are emanated or is said to be epicenter. So epicenter is the place from where surface waves starts to emanate, and focus or hypocenter is the spot from where P and S waves or body waves starts to emanate. So these points, hypocenter and epicenter, are the points from where body waves and surface waves are emanated. So this is all about fundamentals of seismic waves and Earth's structure. And in the next session, we will discuss more about how to measure these waves, how to record these waves using seismograph. That technique is said to be seismometer, and more about seismometer and its applications of seismology will be discussed in the next session.